This is a very old dream of the humanity. When you are looking at the sky, you are looking at stars. Do we have other planets, other worlds?
Early in 1994, astronomer Michel Mayer and his team began using this 2-meter telescope to track a sun-like star named 51 Peg in the constellation Pegasus.
Already after a few weeks, we saw something special with this star.
Mayer was looking for planets orbiting stars outside of our solar system, extrasolar or exoplanets.
The planet itself was not visible. To detect a planet, we need to measure the velocity of the star night after night. And due to the orbits of the planet around the star, sometimes the star is moving a little bit in your direction, and sometimes is moving a little bit away. This is the velocity, and this is the time. And so you can see every time you measure the velocity change as a function of time. Only after a lot of measurements, a lot of nights, that we have the possibility to detect really the presence, the existence of a planet.
Those distant stars are only visible from Earth for a few months out of the year due to the Earth's own orbit around its sun. In July 1995, Mayer resumed watching 51 Peg.
This was the most exciting time for us because we have just confirmed and tested that really we still have the same periodic chain with the same amplitude, the same period. And so at the time we are sure that it was a planet. So we decided to publish this in the end of August 95 in the very famous scientific journal Nature.
This discovery has been expected for a lot of centuries.
It's one of the fundamental discoveries this century in astronomy.
We always wanted to know if we are alone in the universe or not. And we are looking for different kinds of planets.
It was for the mankind really a new step.
It's a step in the search for life elsewhere in the universe.
Nyon, on the outskirts of Geneva in Switzerland. The home of Michel Mayer. Last month, the family celebrated youngest son Julien getting his PhD.
He did a PhD in neuroscience. It's studying the brain, and it's much more complicated than the universe. So, and I'm very proud of him.
Michel often brought his family to Haute-Provence and other observatories to watch the cosmos together.
Yeah, he brought me a lot of interest into different fields, physics and astronomy.
You're proud of him?
Yeah, sure, yes.
As any wife of her husband. When we have discovered the 51 Peg, it was so big trouble for the family. We have been obliged to cancel the vacation and so on. So she said, oh, one it's okay, but not a second one, please. But no, you know that we have 70 or something like this.
About 160 exoplanets have been found so far by planet hunters around the world. So how are these planets formed?
Exoplanets or planetary systems, are only a byproduct of the formation of the stars themselves. If we are looking in the disk of the Milky Way, of our galaxy, with modern telescope, we can do images of big pieces of interstellar matter, and sometimes this piece of interstellar matter collapse to form new generation of stars.
These young stars are surrounded by disks of dust, ice or gas.
When the gas contracts, you will have an increase of the rotation of the gas, and part of the gas will be too fastly rotating to fall down on the star. This disk is the nursery for the formation of planets. And when you achieve a big ball of maybe 10 times the mass of the Earth, it's the gravitation of this this protoplanet is large enough to attract the gas of the nebula and to fastly drive the mass to maybe 300 times the mass of the Earth and to produce big planets like Jupiter.
Before the discovery of 51 Peg, astrotheorists believed that only huge planets the size of Jupiter or larger are able to tug their stars fast enough to register on telescopes on Earth, and that they would only be found far from their stars in orbits taking years. But Maillet's team found 51 Peg only took 4 days to orbit its star.
So this was a big challenge for theoreticians at the time. So it's to understand how it is possible to produce big planets like Jupiter, but very close to the star.
What is the ultimate goal of your search?
Ultimately, evidently, this is a big challenge, is to answer to this huge question, are we alone in the universe? And evidently, we need first to discover this very teeny planet like the Earth around other stars, and then after to analyze the chemical composition in the atmosphere of this planet and to see if we can detect some small chemical changes due to life and to answer this huge question. This is the International Balzan Prize and given in science and humanities.
A plethora of awards attest to Michel Maillet's achievements.
I received the Einstein Medal in 2004 in physics. It's not a prize, but it's a book written on the discovery of exoplanet, written with one of my friends, Pierre-Yves Frey. And in fact, we received a prize for this book.
So you will soon have one more, the Shaw Prize. How do you feel about that?
It will be a very important one. This shows the international aspect of science. I feel very honored to be part of this team.
Congratulations.
Merci. In fact, I have 3 other prizes I receive. It's 3 grandchildren. I believe it's fair to recognize the help I receive from all my family in all this long life in astronomy, and evidently first from my wife.
I met him when we were students together. So we studied in Lausanne, in the university in Lausanne, and we came from the same village, and we met in the train going to Lausanne. He studied physics, and it was a large topic, so he himself didn't know exactly what he will be doing after his studies.
At the end of my studies, some offer exists to come and to do a PhD in Geneva.
The University of Geneva. It was the late 1960s when we on Earth were beginning to grasp the formation of spiral galaxies.
I did my PhD in the spiral structure of the galaxy and in theoretical astrophysics. And then, at the end of my PhD, I need to have material observations for velocity of stars. And it was very difficult to find this information in catalogs or things like this. So I've decided to build my own instrument.
That first instrument, built some 35 years ago, still stands at Haute-Provence Observatory.
This was the first of all the instruments developed here to measure velocities of stars. It was not aimed to search for planets, but this was really the first one of this series of instruments going to higher and higher precision to permit the detection of planets. And this was done 35 years ago.
Telescopes have since set their sights much farther, even since the discovery of 51 Peg.
It's very strange to imagine that the first exoplanet have been discovered with this rather old and moderate-sized telescope. It's only less than 2 meters, the size of the mirror. And right now it's true that we are developing new instrumentation.
In Chile, Michel works regularly in that South American nation where the clear skies are ideal for stargazing. At the La Silla Observatory is this 3.6-meter telescope, and this 8-meter one at Paranal Observatory.
It's more than dreaming. We are doing the first study to see what kind of spectrometer we can put on a huge 100-meter telescope.
You can also imagine the Eiffel Tower here. It's about that. So it's not much smaller than the Eiffel Tower.
Some of Michel Mayer's postgrad students at the University of Geneva are involved in testing instrumentation for this telescope of the future.
To see how much we can improve the calibration of the instruments. We aim at 1 centimeter per second precision. The telescope is of course very important, but the instrumentation that you put on the telescope is maybe even more important because it determines a lot of new research in many fields of astronomy.
Would this be the biggest telescope ever built?
Yes, definitely.
Yes, by far. It will be the largest. It will be in operation probably in 10 or 15 years from now. It will be initiated by Europe, but if I can dream, I would like to see China's colleagues joining the club to do, because this will be, it's out of the possibility of no more countries, but continents.
To date, the biggest optical telescope is in Mauna Kea in Hawaii, used by Jeff Marcy.
Do you consider American astronomer and fellow Shaw Prize winner Jeff Marcy to be your greatest rival?
No, certainly not. It's true that we have a strong competition between both teams. This probably is very big stimulation, not to sleep on the results. Last year I was in Japan, in Kyoto, and Jeff Marcy and myself was attending this conference, and one of China's colleagues, Daglin, gave us these things, and we were laughing to do some competition between both Jeff Marcy and myself. So you see, we are perfectly able to have some play together.